after having looked at the demand side, the people who buy milk, we're now going to look at, this is the milk market in Montreal, we're now going to look at the supply, which would be the dairy farmers, the people who are selling milk. So the way we look at this in economics is we imagine a function, a mathematical function in which we've got, first of all, the supply of milk, and this would be added across all the various dairy farmers bringing milk to Montreal, let's say, and what factors, these various factors that would determine whether a dairy farmer could bring milk. I assume the number of cows they have, how big their farm is, the weather conditions. The farmer would have to, the technology, how they produce milk, they'd have to take all of this into account. So we're going to look at an example, a way to look at, imagine this problem is to think of the island of Montreal, and I'm going to put myself here on top of the Olympic Stadium, if I will, and I'm going to ask all these dairy farms. Here we've got the U.S. border. Various dairy farmers, little dots over the place around here. We're going to ask them how much milk can they bring to Montreal over, I don't know, let's say a 4-week period or something like that. Now, if they ask me, well, how much milk do I need? I'm going to tell them, look, I got lots of hungry kids, thirsty kids here. They want milk. So however much you can bring, don't worry about it. I'll make sure that it's that you'll have buyers for your milk. So that's not the issue. It's just that the issue here. The question is technically how much can you bring? So I'm going to do a survey of them all. And what I'm thinking about here is a hypothetical question is, well, what factors will determine how big is their truck, how much milk they have? These are the various, then that's what we're looking at. What factors would? So I looked in your textbook, and according to the textbook, this is the list of items. Well, the first question, of course, that the dairy farmer is going to ask me is like, how much milk? How much I'm going to pay for the milk? So that's the price of milk. That's going to be a key factor. I mean, if I'm only paying 50 cents a liter, they're probably not going to bring the milk. So some of the other factors that are important are things like input prices. That's the technical term we use for things like, well, basically wages. You got to pay the driver of the truck, the cost of cow feed. Price of related products, cheese. Well, I mean, instead of bringing the milk to Montreal, the guy could be selling it to a cheese factory nearby. That's kind of said leather jackets. The guy could be in the leather jacket business or the milk business, but then the cows wouldn't exist anymore. There'd be a short-run business. This is your textbook's got things like expectations, information, the number of suppliers. Each textbook is going to be different. Each market is going to be different. One of the quite relevant here is technology. Of course, the guy's got to know, or the dairy farmer has to know how to produce milk. And I'll look at this one here. Taxes, that's going to be quite important later. Weather, yeah, if it's a winter day, he's less likely to drive into Montreal, and so on. Subsidies, as we've seen before, this is when for example, the government were to give money, he'd have to know about, or she'd have to know about how much subsidies are being paid in case they produce milk. Now, what I'm going to do is once again conduct a thought experiment in which I'm going to keep all of these factors here frozen. I call this ceteris paribus. Keep everything constant, and the only thing I'm going to change is the price of milk. And I'm going to do a survey of all the dairy farms and ask them how much milk they'd be willing to bring in at different prices. So all of this is held constant for my first experiment. Well, of course, I'm going to conduct another experiment, which I'm going to change one of these items, in which in the case then I've got to do a whole new experiment, and let's take a look at what this means. So once again, we've got this graph again with the price, not Y, but price P on the vertical axis, and I'm going to put not X, but I'm going to put Q for the quantity, or millions of liters, on the horizontal axis instead of X. So my first experiment, call it the benchmark scenario 1, I'm going to survey all of these guys, and I'm going to say the price is $3. I will pay however much you want to bring into Montreal. I'll give you $3 a liter. So here I've got my little map of Montreal. This is like 20 kilometers, 40 kilometers, 60 kilometers. So we got the U.S. border here as well. So at various dairy farms, and I don't know, this guy up here, this guy over here, this guy. One guy says, I'll bring 10,000 liters. I've got so many cows. Another guy says 20,000. Remember, I've told them, don't worry about it. I've got lots of thirsty kids. You make sure that the milk is delivered and I'll worry about the distribution afterwards. That's my problem. So anyway, there might be a guy near the U.S. border that says, $3 is not worth it. I'm going to go to the States with my milk, or Quebec. So some guy over here near Trois-Rivières, Quebec City. Anyway, I need a number here, and I'm just going to say, for the sake of argument, let's say when I do this survey, I add them up, 10,000 here, 20,000 there, 40,000, whatever the number is, I come up with 50 million liters. Okay, that's 50 million. It's not a 6, it's a 50. Okay, you can see it down below. We can call that point here like point E. So I'll just call this point E. Okay. So now I say, oops, guys, I'm sorry. Keep in mind, everything's frozen. I'm just going to say I can't pay you $3. I can only give you $2.80. Now, I'm assuming, again, these guys are, they realize they're all honest. They're telling me the truth. There's no game going on here. It's not really a negotiation. The ones that are obviously closer to the States, they might just say, no, it's not $3, it's worth it. $2.80, not worth it. So I suspect that $2.80, I'm going to get a new number that will be less than 50 million. And for the sake of argument, let's say it winds up being like 40 million. Okay. Now, once again, I do the same thing all over again. And now they're getting kind of upset with me, maybe. I quote a price of $2.60. Now, you think about this a little bit. The guys that are kind of far away from Montreal, they may complain about being far away, but they've got the advantage that they've got an alternative. If they don't bring their milk to Montreal, they can go somewhere else with it. The guys close to Montreal, at first glance, they may say, hey, that's really neat, low cost. They're making good money if it's $3 a liter. But now they have no choice. They're the ones that are stuck. They might be complaining, hey, $2.60, why are you only giving me $2.60 for it? Anyway, I'm going to get another number here. Let's say it's 30 million. So now I've got only the people that are relatively close to Montreal are bringing their milk, and I can call this point here, this is like point F, and this is going to be point G. And let me do this one again. I've dropped the price down to H, or 240 rather, and I'm going to get 20 million. So I'm losing guys, or dairy farmers, each time I lower the price. So I want to put here line H like this. I got 4 dots here. What I can do next is to I can draw a line through them all. Let's do this. There we go with my line. And that's my first supply curve. You notice I call this scenario 1 here, and I put a 1 down here too because it's my first scenario, my first experiment. And we call this a supply curve. It's a line. In this case, the way I've drawn it, but we still call it a supply curve. In economics, we typically do things like that. We call a curve a line and a line a curve. We sometimes call it the supply curve or supply function. Sometimes, usually curve though. Okay. So anyway, I'm going to conduct a whole new experiment now. I'm going to change one of those things, and I'm going to say, for example. Now, because I'm changing one of the things, not the price, I'm changing some of these other factors, I've got to do a whole new experiment all over again. So let's say, for example, I introduce what's called a toll bridge. A toll is a tax or the price to cross the bridge. So Montreal's on an island. And so now I'm going to say anytime you cross a bridge, take a tunnel or something, the government does this, you have to pay $500 for a truck. Now, incidentally, there are bridges in Montreal from Laval, and the Champlain Bridge, the new one, it was intended to be a toll as well. If you drive to New York City, we're going to look at this idea of tolls later in the course because they may be relevant in terms of congestion in traffic congestion in cities. And I suspect in the future there'll be more and more of these. In any event, we got this toll. What's going to happen now when I conduct my survey? I quote a price of $3. I'm sure there's going to be some of these dairy farms that say, the ones that are farther away, they'll say, hey, look, it's at $3 before the toll, it was worth driving to Montreal. But now, because you got to pay this toll to cross in, it's just not worth it. I'm going to go to Quebec City, Ottawa, I'm going to sit somewhere else. So I suspect this number here would be smaller. Let's call it 45 million. Now, once again, I drop the price. I say, guys, I can't pay you $3. I can only give you $2.80 if you bring this milk to the Olympic Stadium. Well, now I've got, the guy's going to say, hey, look, I got to pay a toll and you only give me less. I suspect this number here, is going to be smaller. So I'll put in 35 million here. Once again, I drop it to 260. Let's put this number over here at 4. It'll be 45, 360. Then I've got 35, 280. And here I'll drop it to 25 here. Be 260. I'd be down at the last case here, 15 million. It would be at 240. So I can now draw, this guy here. We can now draw a new line through here under the scenario 2. So I can call it S2, call this the toll bridge scenario. And the result of this change means that the supply curve will shift to the left. So that means if I do something, a change other than the price, if I change the price, they're just moving down the curve. But if I change something like a tax or a price or a wage or something to do with weather, that would mean that they can bring less milk. I'll write this down here, less milk. Then the supply curve shifts to the left. Well, let's say this toll is very unpopular, which it would be, and as a result, the government gets rid of the toll, which they did with the Champlain Bridge. And now we go back to the benchmark scenario. So we're back in this scenario here, this first scenario. And let's say now there's a new technology, super cow. So the dairy farmers, I don't know, there's some kind of thing that is perfectly safe. It's not hormones or anything. It just has the end result is cows can produce more milk. How much more, I don't know, just more milk. And I don't know, they listen to kind of rap music, some music or something at night, and they produce more milk the next day. Everybody has this technology. It doesn't cost anything. So every farmer has it. So the farmers just have more milk. So now when I conduct my experiment, I quote a price of $3. I suspect they'll have more milk because they can bring more milk to Montreal. So I need another number here. Let me just put it in at 60 million, for example. So now when I draw this pot over here, I got 60, I've got $3, I'm going to put a dot here. Once again, I'll drop it to 280. I only pay them $2.80, so there'll be like 50 million here, which means now I can put another dot here at 50 million, 260 when I drop the price. And all these guys are the ones that are close to Montreal are the ones coming, they're complaining. 40 million. And finally, if I dropped it to $2.40, most of the farms are going to be going elsewhere because $2.40 is not very much to pay for their milk, for the producing, so they can go elsewhere and get a better price. I'll put like 30 million down here. So we've got 40, I got 30 like this. I can join up these pots here, and now I've got 3, so I can call this now S3. This is the super cow scenario. And the end result is the supply curve shifts to the right. So we can say now is if there's more, I'm running out of space here, more milk, then the supply curve would shift to the right. I'm going to summarize all this in a second. So if we change one of those factors and the end result is they can bring more milk, then the supply curve shifts to the right. Let's summarize all of this in a thing. So first I got the price of milk. And then what I did is I kept all of these various things, input prices, wages, cost of cow feed, technology, and so on. I kept all of that constant, weather, taxes, and I just changed the price. But if I change one of these factors, for example, when I change the super cow example, this is the new technology here, which means that the farmers could bring more milk, then the supply curve shifts to the right. If, on the other hand, I change something, for example, the wages of drivers, maybe the price of cheese, so they can sell their milk into a cheese factory, or the taxes go up, the weather is bad. If I change something, in this case I change the toll bridge, they can bring less milk, then the supply curve shifts to the left. So sort of this is going to the right, this is going to the left. Of course, a change could occur also, something like it doesn't have like expectations information. Let's say there's a typhoon or a hurricane in Japan, an earthquake in Japan, tragic for the people in Japan, but I don't think it will have any effect on the dairy farmers. So there's news of a typhoon in Japan, then no change, no shift. So there's 3 possibilities. The supply curve goes to the right, goes to the left, or just doesn't move. So let's take a look at this. I want to take a look now at this idea of the market. And I want to match up what we just did with what we did in the previous lecture with the demand. So let's go back to the data I had before. I think when I did it, the baseline scenario in both cases, so the first case. So I did it when I had it with the demand, the buyers. When I quoted a price of $3, they said they wanted to have 20 million liters. This is all the households. They said they would need 20 million. Then when I dropped the price to 280, some of them said, yeah, bring me an extra liter, or I'll buy some milk or something. At 25 million. At 260, they said they wanted 30 million. Go back and look at the numbers I had in the previous lecture. And it was then, it brought price 35 million. So I drew the line like this, and this was my first so-called demand curve. This is the buyers. Now, what we just did a moment ago, again, the baseline scenario, when I did it with the dairy farmers, I quoted a price of $3, and they said they would bring in $50 million. This is like guys would bring it to Olympic Stadium. Then the second price, I offered $280, and they said, well, some would go elsewhere. Some would bring $40 million, then $30 million, and $20 million. Then I drew a straight line through these dots, and we got the second supply. So we got the two. We matched them up, and you'll notice the lines cross. And put a black dot there. Well, what's this called? Now, a mathematician, mathematically, they'd call this an intersection of the lines. They might call it a solution to the problem. In economics, we refer to this as an equilibrium. I'm going to put the letter E there for equilibrium. Now, equilibrium sort of implies something like, well, I don't know, something balances of some sort. And actually, I'm going to come back to this idea in another lecture because it's actually quite important what we mean by an equilibrium and why we call it this. And in this lecture, I'm not going to do that. I'm going to do something different. Instead, what I'm going to say is, okay, let's say finally we've got the market here, milk, and let's change something. Okay, so let's change specifically. Imagine we put a tax, sometimes called a tariff, on imported milk. Now, imported milk would be milk coming into, well, let's sort of change it. We don't have Montreal here. We'll just say Canada, like, I don't know, just a whole country. So I'm gonna put some kind of a tax on milk. Well, which curve is going to shift in this case? Well, if you look at it, it's a bit like the toll bridge story. Is that, well, it's the supply curve, and it's going to shift to the left. There we go. Now, you'll notice something. When I move this curve to the left, we get a new equilibrium. You can sort of see it. It's up here. E1, I can put a 1 down here to indicate this is the first one, and this is the second one. And I want to pursue this idea a little bit more. If you're curious about this, and how much it shifts to the left, I don't really know. I mean, it's going to depend on the change and so on. You'll notice, too, if you're looking at it from this perspective on the vertical axis, you'll notice that the price would go up when I compare the two equilibrium. And also, if you looked at it from the bottom looking up, you'd see that the quantity would decrease. Well, that's interesting, too. But let's go back, just take this idea of supply curve shift or demand curve shifting and so on. Let's consider a different market, okay? Okay, another example, look at computers in the world. So here I've got 1970, so this is like 50 years ago, and this is the supply and demand curve. I don't know what the price for a computer was 50 years ago. It was probably very expensive. I don't know how many computers there were. There probably weren't too many of them. Well, what changed? What changed over the last 50 years? And you might be inclined to say, well, the desire preferences, now computers are critical in life. You can't live without them. Everybody's got a phone. Maybe people want to have computers more than they did in the past. The old people don't go to ATM machines. They don't like computers. Young people use computers a lot. So you might think the demand curve shifted. I don't think so. If you're curious, you can watch the clip from 2001, how people viewed computers in the past, because what really changed in the last 50 years is that new technology made the computer, specifically the CPU, much smaller and easier to make. So there's new technology that's like supercow. So what we can show is the new curve is probably the supply curve shifted to the right. So we've got S 2020, and you'll notice here we've got E1, we've got E2. You'll notice the price of computers went down and many more people have computers. But what's kind of interesting here is the demand curve for computers didn't shift at all. So it means that people's desire to buy a computer hasn't changed. Our preferences or tastes or anything like that. The only thing that's changed is the supply curve shifted to the right. Let's take another example. We'll consider housing in Montreal. Once again, I'll look at the situation 50 years ago and see what's happened in the last 50 years. Well, what's happened here? Well, there's populations increase. There's more people. So as a result, what's happened? There's more people that need a house or want to buy a house, and the demand curve has shifted to the right. Now, in this case, it's a little bit more complicated because it is true that over time, they've built more houses, too, so the supply curve has probably shifted as well. And there's something else. People's income has increased. People are richer now than they were 50 years ago, so they can afford to buy a bigger house maybe or another house and so on. So these are various changes. But for the quiz, this is just a beginning, introduction to economics. All I'm really looking at is one curve, the initial first curve shift, before we look at, rather, you don't have to worry about other shifts and other examples. Let's take a look. In the next video, we'll look at some more examples of changes like this.